I am Arthur Lutz and I'm a researcher in the Sustainus project. The Indus River Basin fascinates me because water is such a scarce resource there. Every priceless drop of water coming from countless little mountain streams there is vital for the hundreds of millions of people living downstream.
Water, energy and food. Here in the Indus Basin, there are huge stakes for all three. This transboundary area of South Asia, where some of the world's most complicated geopolitics converge, is defined by its lifeline, the mighty Indus River. It is a climate change hotspot and, perhaps more importantly, it is a hotspot for socio-economic development. The population of 270 million people may more than double by 2080, and the demand for resources will rise accordingly. That's where Arthur and the Sustainus project come in. Arthur works in a diverse international team with 3 PhD researchers. How does what's happening in the Indus Basin connect to your work in the Netherlands, Arthur?
Well, at Utrecht University we are using computer models to predict different futures for the Indus Basin region and to optimize the distribution of water. Our project will ultimately create different scenario pathways to achieve the Sustainable Development Goals, or SDGs, for water, food and energy. And in order to make these accurate pathways, it comes down to understanding supply and demand. On the supply side, we have to ask how much water is available and when. And we have to ask how climate change might change the answer to that question. On the demand side, we have to ask how many people will be there, where will they live, what will be on their menus, and how much energy do they need at which times of the year. The answers to these questions are key to what people in the region must do to adapt to changes in the future.
In trying to answer these questions, Arthur builds on previous work done by Utrecht University's mountain hydrology team, led by Professor Walter Immerziel, in understanding the high mountain water cycle. This cycle is changing rapidly, and as a hydrologist, Arthur wants to unravel its dynamic and regional impact.
And the next step is quantifying what these changes in the mountains mean for the people downstream. The starting point of making a model is knowing the supply. If you know the future input of water into the system, you have a good starting point for your models to find out if that supply is sufficient to meet future demand.
It sounds like you're saying you have to know what's going in to know what's going out. So what has your team discovered so far, Arthur?
Well, we found that when making projections for the region's future, climate change will be important. But the more important variable for water scarcity may be something else: downstream demand. Larger populations will put larger pressure on the system. People need electricity, they need water for crops to produce food. Overall, water supply is not changing that much, but the demand is surely going up a lot. People will have to see the basin as one system where water needs to be managed jointly and used very efficiently.
So, if the increasing water demands in the future are to be met, water allocation will need to be optimized over different sectors, and water use will need to be much more efficient, especially in agriculture. Only then can we realize the SDGs for water, food and energy in the Indus Basin. Right, Arthur?
Well, by finding out what can be done and what needs to be done, I'm convinced that the research of our Sustainus team helps pave the way for a better future and can provide incentives to take up water challenges as a global society.